Welcome to Smart Cherry's Thoughts. This is Sai from India.
Firstly, thank you very much, Tudor, for giving me opportunity to interview you for my YouTube channel and podcast.
You're welcome. Thank you for the invitation.
So I've gone through your profile and I came to know that you have a company and you are doing some service. So I thought to tell about the work that you are doing to my audience.
Sure.
So can you please introduce yourself?
Yes, I'm Tudor Girba, and I'm the CEO of Feenk. And at Feenk, we are concerned with making the inside of software systems explainable. So, and to this end, we've invented a new way of programming, which we call moldable development, and we are creating a new development environment, which is called Clamorous Toolkit. And the new thing about it is that it's it optimizes the reading part um, of software development, which is the single largest cost today in software development. And the way we do it is by creating custom tools that summarize the system for us. So basically, we treat every single development problem as including a data science problem, and the way you deal with data science problems is by creating tools that are specific to the problem that you have in front of you.
So when you started this,
When did I start when did we start the project? We started the project. This project started a long time ago, about 13 years ago, or so. The company was started later, about 7 years ago, and the goal of the company is to fund the work and make this make it possible for us to show a new way of a new way in which we can people can develop systems. And everything we do is basically free and open source, which is maybe less usual for a company because yeah, that's our goal. The goal is to educate.
so what problems that you have solved till now?
What problem we solved so far? Um, so we solve. Um, we work with two kinds of companies. So we fund ourselves at the moment as a consulting company, and we deal with two kinds of companies. One kind of company are those that have some sort of a crisis about a legacy system. And the crisis can be induced by different reasons. So one could be that it's just maybe some technology that is no longer supported, or maybe the hardware is going to die, like a mainframe, or maybe just somebody needs to move it to scale the system for whatever reason. For example, to keep up with some demand on the market. There can be all sorts of reasons why people might have some sort of a crisis. The reason we work with people that understand they have a crisis is that they don't need to get convinced about what you do. They just need the solution. So the other kinds of customers we work with are those that are seeking a competitive advantage in software development. And so today, if you look, say, 10 years ago, if you would have said, we're doing DevOps, that would have been probably a competitive advantage for most companies. Today, that's the cost of business. So just doing normal DevOps and some testing is, it's just the baseline, basically. So what moldable development does is gives you the next level of competitive advantage, because you're going to be able to ask many more questions about the system. So this is the second kind of companies we work with, but we've worked with a very large set of problems. So going from legacy all the way to how do we build your systems, and the goal here is to be able to communicate the inside of those systems to all the way to non-technical people, ideally on a strategic level even, and empower them to make decisions, which is typically what doesn't happen. Today, people look at systems as black boxes, basically, and they have a hard time reasoning about what's in there.
The toughest problem that you solve for any company?
The toughest problem. So this is an interesting question, because like we only work with problems that are considered to be either very hard or most often impossible. And so in every problem that we actually face is really different from the previous one. And the reason we do those kinds of projects is because we want to see where this idea of multiple development doesn't apply. So if it is to be, we think that, or we believe that this is a universal way of approaching software development. It complements other techniques that exist. At the same time, it should work in the most difficult situations, not in the trivial ones. So, like a tutorial, like a 30 minutes tutorial, 15 minutes tutorial, those are never indicative to anything, basically, because the interesting parts always happen on the edges in software development. So, so these problems that we deal with, they can be really strange sometimes. So maybe I can tell you a couple. So in one situation, we worked with a large manufacturing company, and we looked at one of the core systems there. It was an administrative system, which was very important to the flow of handling sales and orders. And when we started, they thought this is a COBOL system that was being moved to Java, so it was a combination between COBOL and Java. And then, of course, they also had some JavaScript. It was like a reasonably large system, so about 15 million lines of code. And but then it turned out that actually this was not a COBOL system; it was some other language for which they didn't really have an appropriate description. So the description that they had about the language was no longer true. So when we look at the code, the documentation of the language no longer matched. And the reason was because this language was actually a macro language that was home built or custom built. They only had an interpreter for that, and then it evolved over time. And their documentation about the language was already 10 years old. 10 years old. So, and in the meantime, their implementation of the language, evolved, and they were having another language, which basically meant that, if you look at the, larger picture, you have a very critical system for which you can't even describe the language properly. So, we're not talking about the system. We're just talking about the language. So, so in that situation, it's interesting because we first had to reverse engineer that language in order to start building a parser and importers and so they can build tools that will help us navigate that. So this is one of those typically when people think about systems, they say they can already immediately say this is a Java system or a C# system or a Ruby system. But then it turns out you look closer, it's almost never a Java system, but it's Java plus some middle layer or some other kind of technology, and it's never JavaScript really. It's always JavaScript plus some libraries, which actually turn the whole semantics of the underlying language upside down. So if you do not understand the framework or the frameworks being used, then you're actually not understanding much of that system, which means that in order to have tools that help you reason about that, you have to elevate the knowledge in the tool to go and deal with those problems. So in a situation like this, right, there are a couple of ways to look at this, but one way is to say, well, yeah, it's a technical problem, so you're going to build some technical tools. But the problems that we typically solve is, are at the level of are strategic level. So when you have a system like this, that for example needs to be moved from some, for in this case it was a mainframe, it needed to be moved somewhere else. The problem is that it's it's an end of life type of problem.
So my next question is, uh, in this 7 years of experience as a founder, so you solve different kind of problems, and like you said, you saw different software developing. So you saw the evolution of the software and the tools in the industry. So uh, how will you look at this evolution of software development?
Well, we think that we are creating the evolution of software development. So um, we think that software development will look exactly, or not exactly, but it will look like how we are developing software today in our company, which is that we build, we have. So if we take our environment, which is a normal development environment, or not normal, but it's a development environment, there will be thousands of plugins already. And we build those little plugins for every single development problem. And this is not we don't do it out of marketing needs. We do it as an engineering practice. We do it because we gets us to be more performant to build these kinds of tools. And we think that this is how software development will be happening in the next decade as well. So it will evolve in this direction. Basically, we look at the evolution of software. We'll look at it like first there was code, and then a major improvement when, for example, happened when tests became code. And then another major step was when infrastructure became code. And then every one of these steps, right, tests become code and infrastructure became code, they introduced a new feedback loop that generated a whole new kind of value that we could create with software. And then so the next evolution we see here is that tools will become code. So tools are not going to be something you click on, but it's something you actively program while you actually program your system, which I know it sounds like a little out there, but if you look closer at what a typical data science flow looks like today, it's actually not very far from there, right? Because what data scientists would do is they will take a problem, then they will pick up with the data, maybe, and then figure out how they can clean up the data and get it into a stage that it can be analyzed. And then they will be building other custom tools that will perform the analysis. And these analyses are programmed specifically for that question. And we think that flow should be brought to every single development problem. So dozens of times per day per developer, basically.
So do you have any particular experience that you cannot forget?
The experience that I cannot forget. Oh, yeah, actually, there are a number. So, I mean, this idea started a long time ago, but it's still interesting to see how we sometimes surprise ourselves by facing some problem that we have never seen before, and then and then we're gonna say we don't know how to solve this problem, and we don't even know how to. In fact, a hard problem. We know when we were facing a hard problem when we cannot formulate any hypothesis about it. Like, I think this is wrong, but we cannot even start with that. That's what we think. That's a hard problem, and um, and the way we deal with those kinds of hard problems is not by building an extraordinary expertise and being an expert in everything, but rather applying the same routine. And the routine is that you say, okay, I don't know how to formulate a question about this problem, but I can describe the problem. I'm just going to focus on, for example, I don't know, very recently we were running into memory leaks. So there was, and we didn't know where those memory leaks were coming from, and they were just significant. So, and so because we didn't know where they were coming from, what we wanted to do is that, well, what is a memory leak? Well, a memory leak would be something that you have some state, and then after a while you have a larger state, and you don't expect to have that larger state. That's basically what the memory leak looks like, which basically means that I don't know where this comes from, but if I can just describe the whole state here, and I describe the whole state there, and I look at the diff between those states, then it will probably give me an indication of where the memory leak could come from, which means that now I don't have to necessarily understand where that memory leak comes from. I just have to focus on just building that view and the other view and a diff between them. And once I have those, then I'm equipped. And so the surprising part of this is that it kind of always works. It never happened that this flow of working didn't get us anywhere. So that's the surprising thing.
So what is your approach?
The approach is that we're going to build tools. Like, we're just going to build custom tools for every single problem we had in front of us. So for that, mainframe system, we built a parser that parsed that one. But first of all, we had to find out how to build the parser. So that was the process. But after we had the parser, then we build a model out of that system. And then after we build the model out of that system, we kind of say, oh, what exactly do you want to do? And then we're saying, oh, we want to move this and that to Java. And then we'll say, oh, where do we find this in the code? Well, we find it here. What's the problem? Why is it so hard to move? Oh, it's moved because you have these ties already with the rest of the system. And so at every step of the process, we're never going to read code. So the main problem is today in software is that most of the time developers spend they try to understand the system. They spend it reading. And reading is the most manual possible way to extract information out of a system. So the way we're doing this is that we are basically automating the boring part of the reading, which is just the extraction of information. So every time we say, oh, I would like to see this, something, oh, what are all the places which this one is being used, or whatever that thing is. It can be an interface, it can be a module, it can be, or I have these two little pieces over here. Do they communicate with one another in some form? And sometimes the form, you can see it in code, but sometimes you can't see it in code because it's some configuration somewhere else. And when you're deploying that thing, then they're still going to communicate, but you don't exactly know just by looking at the code. So you need to take all the data, all the setup, all the system, consider it as data, and somewhere there lies the answer, because otherwise you don't have the problem. If there's no system, you don't have the problem. If there is a system, somewhere something causes it and something will expose the problem, which means that now I need to go and find where that thing is. But the looking for this problem it should never be manual. It should never be based on reading, because reading never scales. So that's basically what we do away with. We just we build custom tools that guide us through the system, and by doing that, we basically ask many times more questions than one would when they would just normally read code, and that's what gives a large competitive advantage, basically.
So you developed products for different industries.
Yeah, well, we don't develop necessarily products for them. We help them solve their problems. But indeed, we do work across industries. So we work with car manufacturing, with audio system producers, with telecom companies, transportation companies, or media companies, insurance companies. So lots of different domains, because the focus here is not so much on the domain as it is on the way we can answer questions about software systems. And it turns out that this is not domain specific, that It's technique specific, basically. Now, of course, the domain knowledge is very important. This is why we work together with the teams typically to help. They already know what they want to achieve. They just don't know. The problem is that they don't know the system anymore. Or even worse is when they think they know the system, but the system is no longer the same. Is different than they think it is, right? So every time somebody draws a picture on a whiteboard, that's a manually drawn picture, and it's that's an interesting picture, but that usually depicts what the belief of the author of the picture. It doesn't depict the system. But oftentimes decisions are being made on top of those kinds of pictures, and they are wrong. And the further away you go from the code, the more the decisions will be made on these kinds of beliefs. And so this is why you sometimes end up in situations where a company might have strategic, needs of, we need to move from here to here quickly, and they find themselves 2 years later not having moved an inch, even though they have spent a lot of energy. And the reason why they've done this is because nobody knows the reality anymore. So people are just doing things, but they do not really affect much. And that's basically what happens. So the main thing we're doing is we're just helping them see what their system is. And once you give them a lens to start seeing, they know how to make decisions. They know how to navigate this because they've built the system in the first place. So it's not like they're not able to do things, but you need to show them the current reality. And that's an ability, basically, that we want companies to internalize. And this one has like 3 different aspects. So on the one hand, you have, of course, like new kinds of tooling. So in order for this whole idea of create custom tools to work, we need to have, it needs to be very cheap to create these tools, or much cheaper than the alternative of just manually doing things. So this is why you need a new kind of an environment. So that's what we're building. This is what this Glamorous Toolkit is. You can look at it at gtoolkit.com. It's an open source platform because, as I said, our goal is to educate and show people that this is a new domain that people should be aware of. But then, of course, the technology is only as important as the people that are using it. So the second component are the skills. So you need the new kinds of skills. You need the skill of course, you need the skill of creating these custom tools, but more importantly, you need the skill of asking questions. So you see, when you're able to ask many more questions, the bottleneck is not the answer, but is in what kind of questions are you asking. And so if you're going to ask the same amount of questions that you did before, you're not going to go, it's the value is not going to be, you're not going to add value. But if you then change and start asking many more questions, then you can. Like an interesting parallel here is with DevOps, for example. So if you go from 1 deployment per year to 10 deployments per day, but you're still not gonna do, you're only do 1 experiment on the business level per year, right? It's gonna be better, but the real added value is not gonna be there, right? The only added value, the real added value is created only when the business starts gonna do 10 experiments per day, because then then the business is gonna learn faster. So today the business has a blind spot, which is there's the black box, right? They see the input, they see the output, but they don't know what's in there. And so you can form some mental models with just input and output, but they're just not going to be accurate enough. So if you can see inside and start making sense of that, there's a whole new level of value that you can create. Not only, and the value that I'm talking about here is I'm talking about the business level, because that's where things become interesting. So on the one hand, right, when you have a opportunity in the market, you have to go and execute, say, oh yeah, we have to scale our system 10 times, or gather 10 times finer grained data about whatever we're doing. All of a sudden, then you say, if we do this, we're going to either be able to compete or we're going to gain some more market. And there, if you cannot do it within, let's say, a window of opportunity, then you're going to lose, right? You're going to lose that opportunity. So all of a sudden, the structure of the system, the ability to see inside the system, becomes of strategic importance, because otherwise you cannot move. But then sometimes, and this is where it becomes even more interesting, is that sometimes you have, a cycle of a product is most often, thought about to say, oh, somebody gives you requirements, even in an agile setup. Somebody's responsible with telling you what should be happening, and then they're going to always look at the output. But then you will see that after a while, if things inside are not exactly like how people think about the domain, then over time it becomes harder and harder to move the system. So the design of the system, the internal structure of the system, actually becomes an impediment for whatever people want to, for whatever the way they think. And then you have these rather strange, tensions between people who, oh, let's do this very quickly, and then it then turns out it's one takes a long time, and people say, yeah, but why? And then sometimes it's the other way around happens, like, oh, let's do this one, but they think it's too expensive, but then it turns out it's very cheap to do. And all of these problems, they appear because there are two models, right? There's some mental model of somebody, and then there is the reality. They don't match. And because of this, there's lost opportunity and there's waste that happens. But if you can make this one understandable to these people, then lots of interesting new kinds of opportunities can appear because of this. And our goal is to say, oh, what if you can integrate the CEO into the development environment, so that the CEO could have a conversation with a developer and they would both understand each other? What would that be? So we're doing those kinds of work. So this is on the side where people are seeking a competitive advantage. These are the kinds of projects that we work with. And I know it's kind of, sounds a little bit, maybe a little vague, but that's how we think. And all of these things are very, very concrete, in fact.
Do you solve problems for other parts of the world?
Oh yeah, so we work with
other countries.
We work with we work remotely, first of all, as a company, and we've been working remotely from the beginning. And also most our customers are actually remote, so we're not somewhere, which gives us, on the one hand, this gives us the freedom to work with our colleagues are spread around the world today, but it also gives us the opportunity to work with customers that are anywhere, basically.
So at last, what are your goals?
Our goal is to change how people develop software. Well, in fact, not how they develop software, but how they think about software. So the problem today is that the way we deal with software is not sustainable. We create the body of software grows non-linearly or superlinearly year over year. But at the same time, we have a hard time recycling systems. So we, taking a system and refurbishing for new purposes, taking it apart, adapting it to something new. So from this perspective, we do not behave as an industry. We don't behave any differently from the plastic industry. And this is not sustainable. It might be profitable short term, but it is not sustainable at the societal level. And given that everything that we build today is being touched in one way or another by software, the kinds of characteristics that we have in our systems are kind of an important thing. So we think that this is it's really important that we are able to look inside a system and have a chance to understand what's in there and the decisions that the systems is making, for example, and then be able to adapt the system to new situations. But our goal is less a financial goal for ourselves as it is finding a way that is more sustainable for our industry, but ultimately for the society, because our industry has such a wide impact. That's basically our goal. That's why most of the things we do are free and open source. We want people to go and look at them and go deep into these works. We think there is lots of value there.
So I'll put your web links in the description of this video. People who find our video on YouTube can see the service that you're providing and can take the service of yours.
Okay, thank you.
And also I'll put on the link on the screen, your website link on the screen, and they can see it.
Okay, so people can find us at, our company is called Feenk, Fenk. So they can find us at feenk.com. And the name comes from feel and think, because we believe that we think too much in our industry, and the way we feel is as important. So, for example, if you ask a developer how does she or he feels about working or debugging a legacy system, they might not associate that question with a pleasant feeling, and we think that should change. Working with the legacy system should be beautiful. So that's why the company is called like this. But of course, as I said, we're creating this new kind of a development environment. You can find it at Glamorous Toolkit. It's called Glamorous Toolkit, and you can find it at gtoolkit.com. And Glamorous Toolkit enables this new way of working, which is called moldable development. And you can find some more details about it at moldabledevelopment.com.
So as a founder and CEO, what is your observation about my work? Have you seen any videos of mine on YouTube?
Yeah, I found some of them, and I think it's interesting that you're trying to disseminate different aspects, or rather different from different perspectives, and trying to disseminate them for a wider audience. So I think it's very useful focus.
Thanks, Tudor, for your valuable time and telling about the service that you're providing and also giving answers to some of my questions.
Okay, thank you very much for having me.
So can I put this video on my YouTube channel with your permission?
Yeah, you can.
And also, can I put this audio and video clip on my podcast website?
Yes, you can put it anywhere you want. Yes, you can do whatever you want to do.